Hello and good day. Welcome to the School of RHK. Today we will be studying 6th grade mathematics. The topic is 1.1 Enumeration under chapter 1, that is natural numbers and fractions. What is a symbol or digit in arithmetic? In arithmetic, all numbers are represented by a total of 10 symbols. These 10 symbols are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. These 10 symbols or digits are also called numbers. Except 0, normal numbers are all positive numbers like 1, 2, 3, 4, thus 9, 11, etc. These are numbers that are usually used for calculations and they continue to be infinite. The difference between symbol or digit and number. We already know that 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0 are arithmetic symbols or digits. Suppose we have 24 balls, 16 oranges and 4 mangoes. When we express the quantity of these objects in numeric value using a symbol or a digit, we can write like this. If we express 24 balls in numeric value, we can write 24 using 2 and 4 symbols. We can write 16 oranges using 1 and 6 symbols. And using 4 symbol, we can express 4 for the numeric value of 4 mangoes. Whenever we express the value of a subject or an object using a symbol or digit, it is called then a number. So, if arithmetic symbols or digits are used to express values, they can be called numbers. Any number greater than 9, as we have already seen above, is written by putting 2 or more digits side by side. Any number written in digits is known as enumeration. All these 10 symbols are used in the enumeration. In enumeration, each digit has its intrinsic value, just as the digit 1 has its intrinsic value of 1, digit 2 has an intrinsic value of 2, digit 3 has an intrinsic value of 3. Thus, digit 8 has its intrinsic value of 8, and digit 9 has its intrinsic value of 9. The first 9 digits are known as significant digits. That is why each is called a significant numeral, and the last one is called 0. Note that 0 has its own value of 0, by which the quantity of any subject or object cannot be specified, so it is not included as a significant number. Number system. In arithmetic, there is a total of 10 symbols or digits. Writing a number with symbols or digits is called enumeration. Every symbol or digit is used in arithmetic. Before we proceed further, the knowledge about different number system is essential. In general, there are currently a total of 4 number systems in use, which are called the number system or the calculation method. The first number system is called the binary number system. There are 2 symbols or digits used in a binary system. The first is 0 and the second is 1. The base of the binary number system is 2. Binary system applications can be found on computers. The second number system is called the octal number system. The total number of symbols or digits in this number system is 8. The symbols are 0, 1, 2, 3, 4, 5, 6, and 7. The base of the octal method or number system is 8. The third number system is hexadecimal. There are a total of 16 symbols or digits in this number system. Each of the symbols is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, which means 10, B, which means 11, C, which means 12, D, which means 13, E, which means 14, and F, which means 15. The base of the hexadecimal method is 16. A closer look reveals that the symbols of the binary number system are 2 in total. That is why its base is 2. The symbol of the octal number system is 8. That is why its base is 8. and the total symbol of hexadecimal is 16. That is why its base is 16. In the same way we have seen so far, the symbol or digit of arithmetic is a total of 10. Therefore, its base is 10. In arithmetic, since the total symbol or digit is 10, this number system is called a 10-based or decimal system, or the system of multiples of 10. In other words, the principle of expressing numbers based on 10 is called decimal, or the system of multiples of 10. The 10-based or decimal system, or the system of multiples of the 10 number system, has certain rules. We will look at those rules now. The first rule is to determine the value of the number, or read the value of the number from left to right. Let's assume we have three numbers. The three numbers are 3, 33 and 333. We will write the numbers first in words and then in digits. The number 3 is a single number. As a result, there is no need to consider right or left for reading. So its value is 3. If we read the next number 33, then we will read the 3 on the left side first and then the 3 on the right side. So to enumerate the number, we'll start calculation from the first 3 on the left hand side, but not from the 3 on the right hand side. The next number is 333. So again we will consider the first 3 of the extreme left hand side, and we will say 300 first, and after that we will say 33. So it is 333. We need to remember that we always read the 10-based or decimal system, or the system of multiple of 10 number system, from left towards right. The second rule of the 10-based or decimal or system of multiples of 10 number system is the position of the digit in a number is determined from right to left. The matter will be more clear through example. Let's assume we have three numbers. The three numbers are 3, 33 and 333. We will write the numbers first in words and then in digits. Zeroth or extreme right position. There are no other digits to its right or left if we consider the first number, which is 3. It is a single digit number only. So the zeroth place of the symbol or the digit on the extreme right is identical, which is 3 itself. The next number is 33. 3 and 3 putting two digits together made 33. If we look at the position of the digits, then the 3 that is on the extreme right is the 0th position of 33. The next number is 333. If we put 3, 3 and 3 together, and we can make 333. If we look at the position of the number, then the 3 on the extreme right is the 0th position of 333. To understand very clearly the 0th or extreme right digit of each number, that is 3, 33 and 333, are marked in golden color and enclosed with a golden colored box to indicate that the position of all of them is 0th or extreme right. First position. Since there is no other number to the right or left of the number 3, it has no digit in the first position. If we look at the position of the digits of the number 33, then there is a digit which is 3, considering the 0th or extreme right digit 3 on the left of it. It is marked in red color, considering the 0th or extreme right digit of the number 33. This position of the digit on the left is first. If we look at the position of the digit of the number 333, then there is a digit which is 3, considering the 0th or extreme right digit 3 on the left of it. It is marked in red color, considering the 0th or extreme right digit of the number 333. And this position of the digit on the left is first for 333. To be very clear, considering the 0th or extreme right digit of the numbers 333 and 333, the first digit have been marked in red color and enclosed in a red colored box to indicate their position. Second position. 3 and 33 do not have any third digit. Only the number 333 has a third digit. If we look at the position of the third digit of the number 333, then considering the 0th or extreme right digit of the number 333 has been marked in the green color, where the 0th digit is in golden color and the first digit is in red to make it more clear. Considering the 0th or extreme right digit of the number 333, this position of the digit marked in green color on the left is second. That is, it is now clear that the position of a digit of a number in the 10-based or decimal system or the system of multiples of 10 number system is always determined from the extreme right towards left, and that the position counting of the digit starts from 0 and continues to increase if we move towards the right to left. The third rule for 10-based or decimal system or the system of multiples of 10 number system is the place value and the intrinsic value of a digit on the 0th or extreme right of the number are the same. The matter will be clear through example. Let's assume we have three numbers. The three numbers are 3, 33 and 333. We'll write the numbers first in words and then in digits. To understand very clearly the zeroth or the extreme right digit of each number, that is 3, 33 and 333 are enclosed in golden color, and for further clarity, the position of all these digits is enclosed with the golden box to indicate that they are at zeroth or at extreme right position. Since these digits of 3, 33 and 33 in golden colored box are the zeroth of or extreme right of the numbers, in the zeroth or extreme right position of each of these digits, the place value and the intrinsic value are the same, that is 3. To understand very clearly the zeroth or the extreme right digit of each number, that is 3, 33 and 333 are enclosed in golden color, and for further clarity, the position of all these digits is enclosed with the golden box to indicate that they are at zeroth or at extreme right position. Since these digits of 3, 33 and 33 in golden colored box are the zeroth of or extreme right of the numbers, in the zeroth or extreme right position of each of these digits, the place value and the intrinsic value are the same, that is 3. Rule number 4 in the 10-based or decimal system or the system of multiples of 10 numbering system is any digit on the next to the left of the zeroth position or extreme right of the number is called the first position and is 10 times its intrinsic value. The matter will be clear through example. Let's assume we have three numbers. The three numbers are 3, 33 and 333. We'll write the numbers first in words and then in digits. Since there is no other digit to the left or right of the number 3, its next to the left position or the first position has no digit. The next to the left digit, considering the zeroth position or extreme right of the other two numbers, that is 33 and 333, is being marked in red color. And to make it very clear, enclosed with a red colored box to indicate that their position is next to the left or first position, considering the zeroth position or the extreme right to the left. Since these two 3's in the red colored box are the first digit from extreme right to left of the number 33 and 333, the position counting of these digits will be 1. The place value of each of these two digits in this first position will be equal to 10 times its own or intrinsic value, or 3 into 10 equal to 30 for both 33 and 333. Let us apply the formula we have learned. In the formula, we have learned that the value of a digit in any position in a number is equal to 10 to the power of position counting multiplied by the digit's intrinsic value. As the position changed from 0th to 1st or 1 here, so the position counting is 1 and the digit is 3. So we can calculate 10 to the power 1 multiplied by 3. The value of the 10 to the power 1 is 10. So we multiply 10 by 3 and we get 30. Thus the formula proves the rule that the place value of a next to the left of the 0th position of the number is called the first position and is 10 times its intrinsic value. Rule number 5 in the 10-based or decimal system or the system of multiples of 10 number system is any digit on the next to the second left of the 0th position or extreme right of the number is called the second position and is 100 times its intrinsic value. The matter will be clear through example. Let's assume we have three numbers. The three numbers are 3, 33 and 333. We will write the numbers first in words and then in digit. Since there is no other digit to the left or right of the number 3, so it has no digit next to the second left of the 0th position of the number. Again, the number 33 has two digits for the right to left, so there is no digit next to the second left of the 0th position of the number. To make it clear, the digit considering on the next to the second left of the 0th position or the extreme right of the number, that is 333, is being marked in green color. To visualize, it's very clearly enclosed in a green colored box to indicate its position is on the next to the second left of the 0th position of the number. The position counting of this digit will be 2. The place value of the digit in the second position will be equal to 100 times its intrinsic value, or 3 into 100 equal to 300. Let us apply the formula we have learned. In the formula we have learned that the value of a digit in any position in a number is equal to 10 to the power of position counting multiplied by the digit's intrinsic value. As the position changed from 0 to second or 2 here, so the position counting is 2 and the digit is 3. So we can calculate 10 to the power 2 multiplied by 3. The value of the 10 to the power 2 is 100. So we multiply 100 by 3 and we get 300. Thus, the formula proves the rule that the place value of a next to the second left of the 0th position of a number is called the second position and is 100 times its intrinsic value. So it is clear now that in a number, if a digit moves right to left, it changes its position starting from 0th and oblique or from the extreme left, and gradually position counting increases. And to find the value of a digit in any position of a number is equal to 10 to the power of position counting multiplied by the digit's intrinsic value. All the students are requested to try this formula to test the value of a digit in any number. Rule number 6 in the 10-based or decimal system or the system of multiples of 10 number system is the value that a digit in a number expresses for its position is called the place value of that digit. The matter will be clear through an example. Let's assume we have three numbers. The three numbers are 3, 33 and 333. We will write the numbers first in words and then in digits. On the 0th or extreme right of the numbers, that is 3, 33 and 333, the digits are 3, 3. Here these 3 3's are marked in golden color, and a golden colored box is used to mark them more clearly to visualize their position. The intrinsic value and place value of the digit in the 0th or the extreme right position are the same. The value of these digits will be 3 for all the numbers, that is 3, 33 and 333 in this 0th position. Since there is no other digit to the left or right of the number 3, there is no digit in its next to the left of the 0th position. Now the number that is 33 and 333 have digits in the next to the left of the 0th or the first position from the right to the left. These two 3's in the first place are marked in red color and enclosed with a red colored box. As we know, these two 3's have intrinsic value which is 3, but due to the change in position from 0 to the first position, the place value of these 3 digits will be 3 multiplied by 10 equal to 30 for the numbers 33 and 333. In the same way, the number 333 has a digit next to the second left of the 0th position. The digit 3 in the second place has been marked in green color and enclosed with a green colored box. As we know, digit 3 has an intrinsic value which is 3. But due to the change in position from 0 to the second position, the place value of the 3 digit will be 3 multiplied by 100 equal to 300 for the number 333. So It is clear that even the digit 3 has been used in different places or position of the number and did not change its intrinsic value in any place or position. But the place value of the digit 3 has been changed from 3 on 0th place to 30 in the first place and 300 in the second place, as the place value is represented in connection with the position of the digit in the number. And it tends to increase if we move further from right to left positions. Rule number 7 in the 10-based or decimal system or the system of multiples of 10 number system is: when a digit moves to the left from the right 1 by 1 position in a number, its place value increases 10 times of its intrinsic value in comparison to the just previous position place value. The matter will be clear through an example. Let's assume we have a number. The number is 2, 1, 2, 3, 6, 3, 6. Starting from the right side, the 0th position digit is 6. As 6 is in the 0th position, the value of this digit will be 6. The first digit on the left side is 3 in consideration of the 0th position. The first digit 3 on the right will have its own value 3, but due to the first position, the place value will be 3 multiplied by 10 equal to 30. The second position digit on the left is 6 considering the 0th position. The second digit 6 on the right will have its own value or intrinsic value 6, but because of the second position, the place value will be 6 multiplied by 10 multiplied by 10 equal to 600. The third digit on the left is 3 considering the 0th position. The third position digit 3 from the right will have its intrinsic value 3, but due to the third position, the place value will be 3 multiplied by 10 multiplied by 10 multiplied by 10 equal to 3000. In the same way, the value of 4th, 5th and 6th place has increased 10 times for its previous place values multiplied by the respective intrinsic values. A closer look here shows that the digit 3 in the first and third places has the intrinsic value of 3 in both positions. But because the position from right to left is first and third, the place value of the digit 3 is 30 in the first position and 3000 in the third position. As the position has shifted twice here from the digit 3 from left to right, from the first to third position, it has increased its value by 2 times 10. That is 30 times 10 times 10 equal to 3000 in the third position. Thus, it proves that when a digit moves to the left from the right position one by one in a number, its place value increases 10 times of its intrinsic value in comparison to the just previous position place value.
Thank you for watching the tutorial. If you have any question, please send us email to rhkstore@gmail.com or write in comment section. We would appreciate if you subscribe, give us a thumbs up or a like. Please do share with your friends. And to receive new tutorials, do not forget to press the bell icon. Stay home and stay safe.